Well, Ian, you could you could do this as an extra credit project.
Okay.
You could compare the payouts under the two options. One option is to take a lump sum payment.
Okay.
The other option is, however they do it, maybe a payment once a year for 20 years, whatever it is. And then compare the present value of the two options. Obviously, if you get it in a lump sum, you know what the present value is. It's that lump sum, because you get it right away.
Yeah.
But if you defer, and you take, say, 20 payments over 20 years, then implicitly, they are using a certain discount rate. And you could figure out what that is.
I actually checked one time what the discount rate they were using was.
Yes.
They used 4%.
4%.
Which I thought was a little bit high considering what interest rates are right now. That's when the
Yeah.
Powerball was so high.
Right.
I was actually looking at it and I calculated the expected value too to see if it was positive.
Yeah,
But it was
By the
still
way,
like negative $7 on a $10 ticket.
I'll make this extra credit project open to everybody, not just Ian.
I know, but now I don't feel special.
Have a donut.
How much extra credit?
But Ian, you were the one that came up with the extra credit project.
So does that mean
So-
that I can take like a little bit off the top as like a fee from everyone?
No, but it means everybody is
You can sleep better.
indebted to you.
That's a good idea.
Now are you
Yeah.
class or?
Exactly.
This month is
Okay. All right, okay, so let's consider the following problem. Suppose you have a monopolist, a single seller, that can set the price of its product. Only in this case, the monopolist is a price discriminating monopoly. That means it can separate his or her customers into different groups and charge each group a different price. So for the same commodity. Now, in order for this to work, in order for this to be feasible, the product cannot be resold. Because if you're charging two different prices for the same product, then you would create the opportunity for the buyer arbitrage. Okay, so we're going to assume that this product cannot be resold by the buyers. Okay, so if that's feasible, then the monopoly will, and the monopoly can separate customers into two different groups, then the monopoly will do so. And this particular example, let's assume group one has this inverse demand curve. 100 minus Q1. Group 2 has a separate demand curve. Perhaps group 2 is not quite as wealthy as group 1. So their demand curve is 80 minus Q2. Notice the vertical intercept is slightly lower. Group 2 is willing to pay at most $80 for this product. And group 1 is willing to pay at most $100. And the monopolist separates them into different groups. Maybe it's this. Maybe group 1 is non-students. Group 2 is students, college students. And the seller, in order to sell you the product, requires student ID to verify with your picture on it and the name of your college in order to verify that you really are a student. Maybe students as a group are a little less wealthy than other people, so that would be the idea. Separate the buyers into two groups, students versus non-students. The cost function of the monopoly is this. It's a very simple cost function. It's just 20 times Q. Where Q, notice that Q doesn't have a subscript. This is total output. So Q is Q1 plus Q2. See, it's the same product. You're selling both groups the same product. You're just charging different prices. So your total output is just the amount you sell in group 1 plus the amount you sell in group 2. The price discriminating monopolist desires to maximize profit. Let's assume. All right. What is our objective function?
Profit, so PQ minus C.
Okay. Profit pi. That is,
PQ minus C.
okay. Well,
You wanna
there are
s-
two different groups.
Do you want to set both of the price equations to equal their Q1 and Q2? So that way you can put them in.
No, let's just break it down. What is profit? Profit is revenue minus cost. Okay. Now, what is total revenue, R, in this case? Josh?
P1, Q1 plus
Right.
Q2.
Yeah. It's just this P1, Q1. That's revenue from selling to group 1. Plus, you're gonna have revenue from selling to group 2. Minus your total cost. See, P1, P2 could be different, so you want to make sure you distinguish between P1 and P2. What do we do next?
Sub in for P1 and P2.
Yeah, sub in for P1 and P2. Let's get rid of P1 and P2. And then we can write P1 as 100 minus Q1 times Q1 plus P2, 80 minus Q2 times Q2 minus C, and now let's substitute in for a cost function. C is just 20Q, and notice Q is just Q1 plus Q2. By doing this, we have now expressed profit as a function of Q1 and Q2. So that's our objective function. And let's write it down over here. It simplifies just a little bit, doesn't it? Profit is a function of Q1 and Q2. And notice we have 100 Q1 minus Q1 squared. But then we have a minus 20 Q1 here. So this reduces to 80 Q1 minus Q1 squared. And then over here, we have 80 Q2 minus 20 Q2, that would be 60 Q2 minus Q2 squared. So now we have profit expressed as a function of Q1 and Q2. This really is the hard part. Once you have that objective function, what do you do? Take the partials. Take partial profit, partial Q1. We'll call that pi 1. Pi 1 will just be 80 minus 2Q1. And what do we do with this partial derivative? Set it equals 0. So right away from this equation, you can see that we'll call it Q1 0. The critical value of Q1 is 40. Then take partial profit, partial Q2. That's pi 2. And pi 2 is just 60 minus 2q2. Put that equals 0, get to q2 equals 30. Critical values of q1 and q2. If we want to be sure that this critical point 40, comma 30, maximizes profit, we should do what? Check the second order conditions. So in order to check the second order conditions, what are we going to need? Right, we're going to need pi 1, 1. And Brianna, what is pi 1, 1 going to be?
Negative 2.
Negative 2. We also need what, Brianna?
Pi 2, 2.
Pi 2, 2. And what is that?
Negative 2.
Negative 2, okay. Finally, we also need what?
Cross.
Oh, pi 1, 2. And pi 1, 2 is what? Is 0. Take the derivative of pi 2 with respect to q1. And you see in that expression for pi 2, there is no q1. So that's enough. So we have pi 1, 1 negative, pi 2, 2 negative. Pi 1, 1 times pi 2, 2 is 4. That is greater than pi 1, 2 squared, which is 0. Therefore, the second order sufficient conditions for maximum are satisfied. And that means at this point, the profit hill will reach its maximum. In 3 dimensions, this looks like a hill. This profit function looks like a hill. And the top of that hill is that where Q1 is 40, Q2 is 30. Furthermore, if you substitute in to this equation, you get pi of 40, comma 30, you get the maximum profit. And the maximum profit in this case, when you plug those numbers in, let's see, I think I have it here, is, if I've done it correctly, 2,005. That would be the maximum height of the profit hill. Furthermore, what prices should you charge each group? Here's the inverse of the curves for the two groups. What price should you charge group 1? $60. Just go back to this equation. And we get P1 star. The optimal price is 100 minus 40. P2 star would be 100, oh, excuse me, 80. 80 minus Q2, which we found 30. 50. So those are the optimal prices. And kind of intuitively, this makes sense. That you end up charging the non-students a higher price than the students. Because the demand curve for the non-students is higher than the demand for the students. Non-students are willing to pay a higher price than the students, so it makes sense for you to charge a higher price to the non-students. You give the students a break. Not because you like students, but simply because this is a strategy to maximize profit. So here's another example of optimization of two choices. Well, I see that we are all here now, so let's take our quiz. Cody, the students demanded that I wait for you before we do the quiz, so.
I appreciate it. I'm late.